Okay, then let's make a quick little video about how you sketch the graphs of the tangent function and the cotangent function. Okay, so we're going to do this in 5 little steps. So let's come over here and talk about the steps that we're going to take in order to graph tan and cotan. Okay, step number 1. Mark your period on the x-axis. Okay, so that's the most important thing, but it's a pretty important thing when it comes to these sine and cosine, these trigonometric graphs, is the period part. Okay, remember for tangent, the period is always pi over b, right? Just 1 pi over b is your standard function for cotangent and tangent. So pi over b, you go on the x-axis and you mark that first. Okay? Then you turn to your vertical shift. Okay, so if you have any vertical shifting going on, you're going to put that on your graph also. Okay, horizontal line representing your middle, right, the midline of your graph. So if you have one of those, you might not have one in your equation. So number 2 step may or may not occur on every single problem. Okay, but if there is one, you should do it second to mark the vertical shift. Okay, so now this is where we're going to differentiate between the tangent and the cotan. If we're graphing tangent, then the third thing we do is you mark your asymptotes. Okay, so we're going to put in your asymptotes. All of these alternative functions have asymptotes. So for tangent, you mark your asymptote halfway or in the middle of your period. Okay, if you have a tangent graph, then you mark the asymptote in the middle of your period. Okay, remember you mark the period on your x-axis in step number 1. So the third step here, if you have a tangent graph, is to mark the asymptote in the middle of the period. Okay, so you might have a different graph. Maybe you have a cotan. So this is a different step, number 3, if you have a cotan graph. If you have a cotan graph, then you will mark your asymptotes at the period. Okay, at the exact period, at the end, maybe at the end of the period. But the period and the end, those are basically the same places. So you're going to mark it at your period. Okay, so that's the difference between a cotangent graph and a tangent graph. Well, okay, one of the differences between tan and cotan is where you find your asymptotes. So for a tangent, you mark the asymptote in the middle of the periods, and for the cotan, you mark the asymptote at the end of your period. Okay, so then the 4th step goes with both of them, and that's to put the 0. You always mark your 0 in the middle of your asymptotes. Okay, all of these things happen in the middle. The middle of your asymptotes, you're going to find your 0, right? For your tangent, the asymptote's in the middle of the period, and that's where your zeros are going to go. Okay, and then your last step is to use your dilation. Okay, so the dilation used to be called, right, your vertical stretch or your amplitude for sine and cosine. But for us, in these ones, they're called dilation. So we're going to mark the dilation. Okay, the dilation always goes in the middle of your 0 and your asymptote. And they're different for tangent and cotangent. Okay, for a tangent graph, the dilation goes to the right and up. So if this is your 0, you go right half and then up 1 for tangent. I guess we'll talk about that here in the middle, so we don't really have to worry about that right now. Okay, but those are your 4 steps, or rather 5 steps, when it comes to graphing tan and cotan. Okay, first you mark your period, then if you have a vertical shift, you put that on there, and then you mark your asymptotes. For tangent, they go in the middle of your periods, and for cotan, they go at your periods, and we'll talk about why that is in a second. and then you mark your zeros in the middle of your asymptotes, and then you do your dilation in the middle of your zero and your asymptote. Okay, so those are your steps. Now let's see if we can put them into practice with some actual problems on my not very clear worksheet. So this one says y equals 2 tan x. Okay, so it's y equals 2 tan x. So the period is going to be, since we don't have a number in front of x, your period is just going to be pi. That's the standard period for tangent. If we don't have a v value, then that's what we put for the period. So step number 1 is coming over and marking pi on your x-axis. So somewhere over here you make a tick mark and call it pi, and then you make another tick mark and you call it 2 pi. So now we're looking at the midline. Notice there's no number plus or minus after your tan, so there's no shifting, so we have a midline through the x-axis. Okay, so nothing changes there. Now we're going to put in your vertical asymptote. This is a tangent graph, so we're going to put them in the middle of the period. So if we had a period of pi, that means your first asymptote goes here at pi over 2. And then your second asymptote goes here in the middle of pi and 2 pi. Okay, at 3 pi over 2, or 1.5 pi. Right? And if you wanted to be complete and concise, we would come one in the negative direction at negative pi over 2, and we would put one over here also. Okay, so the reason this happens, okay, let me tell you the why. Tangent is a ratio of sine over cosine, right? It's the y value over the x value, sine over cosine. So wherever cosine is 0, the tangent has an undefined value, right? And every time we have an undefined value on a graph, that means we have an asymptote. So this is the graph of cosine, right? Cosine looks something like this. Notice where the asymptotes are, right? The asymptote of tangent happens everywhere that the cosine is 0, which is at pi over 2 and 3 pi over 2. Okay? That's why you put your asymptotes in the middle of your period, because that's where cotan is going to be 0. So now that we have that understanding, let's continue with our next step, which is putting in the zeros. So wherever cosine has a max or a min, the tangent has a 0, because it's 0 over 1, and 0 over negative 1, right? Those are the values, so we get 0. So the tangent has a 0 in the middle of your asymptotes. Okay, now here is where you put your dilation. So for your dilation, think about 45 degrees. 45 degrees, or pi over 4, is halfway, right? What's the tangent at pi over 4? Hopefully you know from your unit circle that the tangent at pi over 4 is 1. So usually at pi over 4, tangent is 1 unit above your midline. Okay, that's usual if there's not a dilation. Well, our graph does have a dilation. In fact, it's a dilation factor of 2, right? There's a 2 in front of our tangent. So rather than having our point 1 unit above the x-axis, it's going to be 2 units. So this is how we do a dilation. This is how we express, or we show your dilation, not dilation, your dilation in tan and cotan, is by how high is your 45 degree point above your x-axis. So this one has a dilation factor of 2. There's a 2 in front of the tan. So our 45 degree point is 2 units above the midline, in this case the x-axis. Okay, so then we do it to the left also. Negative pi over 4 is going to also be 2 units below your midline. So that's how we do our dilation, is we do that many units above your middle, where normally it's a dilation factor of 1. So everywhere between your 0 and your asymptote, is where you put your dilation, 45 degrees. Right? At every 45 degrees, we have a dilation factor. So halfway between your 0 and your asymptote, this is where you do your dilation. Okay? So those are your points. Right? These are the 3 points that we need in order to graph a tangent. You need your zeros and you need your 2 dilation points. Now the graph of tan is a fairly simple graph. It looks kind of like a cubic. It starts close to the left of the asymptote, goes through your dilation points, and then ends to the right on the asymptote. And it repeats over and over and over, just like sine, cosine, and tangent do. They continue to repeat that same pattern over and over and over until you run out of graph space. All right, let's practice another one. Tangent of 2x minus 2. Okay, so first we do the period. So it's always 1 pi divided by this number. So pi divided by 2 is just a period of, well, pi over 2. Right? Nothing to simplify, nothing to reduce, just pi over 2. So on your x-axis, we come over and we mark at pi over 2, and then we mark it again. And what is that second point? What's pi over 2 plus pi over 2? That's just 1 pi. So your second period is going to happen at 1 pi. The next step is your vertical shift. So notice we have a minus 2. So we're going to go down 2 units and make your horizontally dashed line, right? This is your vertical shift. All of your points have been moved down 2 units. Okay, now we go to the asymptotes. Asymptotes always happen in the middle. So this time it's going to happen at pi over 4, which is that point. And then it's going to happen at 3 pi over 4, right, which is this middle. The middle of pi over 2 and pi is 3 pi over 4. Then maybe we can even come in here and put one at negative pi over 4, right, just to be clear and concise. We can do that. Okay, once you have your vertical asymptotes, you put in your 0. So we have a 0 in the middle of your asymptote. So we have a 0 at 0, right? 0 degrees, 0 radians. We have a 0 at pi over 2, and we have a 0 at pi. And now we look to our dilation. So we have a no number in front of tangent, which means we have a dilation of 1, or your standard. So we go halfway between your 0 and your asymptote, and we go up 1 unit. To the right, and we go halfway to the left, and we go down 1 unit. Okay, we continue using that pattern, and so we have filled up all of our period places, at which point we connect your 3 dots with your tangent line that go through your dilation points and then through your 0. Okay, starts close to your left asymptote, finishes close to your right asymptote. So there's the graph of your tangent function. Okay, let's check out what changes with a cotan graph. So here we have the cotan x minus 3. Okay, so your b value is just going to be 1, right? There's no number in front of x. So our standard period is pi. So on your x-axis, we put pi and we put 2 pi because that's the second thing after pi. So for cotan, you put your asymptote at the period. Okay, cotan, the asymptote goes at the period. So let me tell you why. Remember, cotan is the reciprocal of the tan, which means cotan is a ratio of cosine over sine. So everywhere sine is 0, your graph is going to have an asymptote. So remember what the sine graph looks like. It goes through the origin, and then has a 0 at pi, and then has a 0 back at 2 pi. Okay? So cotangent has an asymptote everywhere sine is 0. And sine is 0 at 0 and pi and 2 pi. So that's why we put your asymptotes there as opposed to like we did for the tangent. Okay, so that's the change. Everything else stays the same. We put our zeros in the middle of your asymptotes, just like you did for tangent. Your zeros go in the middle. Now here's something else that changes. Okay, pi over 4 is here, is to the left of your 0, right? This 0 is at pi over 2. Well, the cotan at 45 degrees, which is here, right? This is pi over 4. This is your positive 1. So this is your dilation. For cotangent, the positive side is on the left of your 0, and the negative side is on the right of your 0. So this is another thing that changes from tan to cotan, is we go left halfway and up 1, and then right halfway and down 1. Okay? Because this 0 point here is at pi over 2, and the tangent of pi over 4 is positive 1. So pi over 4 is to the left of your 0, so we go left to pi over 4 and then up 1. And then your graph, of course, starts at the asymptote on the left, goes through your dilation through your 0, and then ends up on the right side. Okay, so this is a graph of a cotan with 0 at the period, asymptotes at the periods and 0 halfway. Okay, and then it's up on the left and down on the right, so it shrinks. The y values are decreasing from left to right, where for the tangent, the y values are increasing from left to right. Sorry, I just got reminded about this -3. Okay, so let's do this all over again, only moving all these points down 3 units. Okay, pause again and erase all this. Sorry, I just got reminded about this -3 part. The -3 part, yes, we need to do that second. So you take your y and you move all the points down to here. Okay, so sorry, all those points that we just did would have been great if they were all 3 units below where they were. Okay, so nothing changes. We still put your zeros in the middle. Right, the zeros still happen in the middle of your asymptotes. You go left halfway and up 1, and right halfway and down 1. Okay, so all of your other steps still happen. They just happen down here, 3 units below where we had them all happening.
I get to redeem myself.
Okay, so your graphs should look like this, which is exactly what they looked like a second ago, only down 3 units. So I should have done that second, I should not have moved my screen up so much and lost sight of that -3. Right, because that's really the second step, putting in that horizontal asymptote. To see what happens if you don't. Now we have to move all of our points down 3 units. Okay, so all your counting happens on your midline, right? 3 units down. So the middle is still the middle, right? Halfway left and right are still halfway left and right. It's just not happening on your x-axis. I apologize. Thank you for that reminder, my dear student. Okay, let's run through one more, see if we can get through it. So we start with the period, right? So here we have the 1/3. Remember, the period is always pi divided by that b value. So rather than dividing by that fraction 1/3, we multiply by its reciprocal. So multiply by 3 over 1 gives us a period of 3 pi. Okay, so we come over here on our x-axis and we mark 3 pi and 6 pi. That's 2 complete periods. We put our asymptotes through the period of 6 pi and 3 pi. Okay, just like we always do with cotangent. Cotangent has asymptotes at the zeros, and then we put your zeros right in the middle of your asymptotes, always in the middle. Okay, and now we have our last thing is a scale, or not a scale factor, but a dilation value of 2. So halfway to the left between your 0 and your asymptote, we come up 2 units. Halfway to the right, we go down 2 units. Okay, so halfway to the right, you go down, and halfway to the left, you go up 2. Remember, this is what we do with cotangent. Your 45-degree point is to the left of your 0. Okay, and then you make your swooping graph that starts next to the left asymptote, goes through your 3 points, and ends up on the right asymptote. And then there we have your graph of cotan. Okay, so remember the steps. First, you put your period on the x-axis, and then you mark your vertical shift, which I forgot to do. Okay, and then for tan, your asymptotes go in the middle of the period, and for cotan, your asymptotes go at the period itself. Okay, and then you put your zeros in the middle of your asymptotes, and then you mark your dilation in the middle of your zeros and your asymptotes. Okay, so hopefully this was a fresh tutorial and you have learned something about graphing tangent and the cotangent functions. Thanks. Have a great day.